Today we are going to be going through logarithm. Logarithm. Now, there are so many things that you need to take note of in logarithm. You remember we did a class on indices, the laws of indices, where I explained that when you have 10 raised to power a times 10 raised to power b, is going to give you 10 raised to power a plus b. So in indices, you add the powers when it is multiplication. So in indices, multiplication becomes addition. Multiplication becomes addition in indices, while division becomes subtraction. Division becomes subtraction. That is for indices. But in logarithm, the case is different. In logarithm, addition becomes multiplication, subtraction becomes division. So these are things that you need to understand. So like I told you in class, logarithm is the inverse of what? Indices. Logarithm is the inverse of indices. Now, I'm going to explain bit by bit again so you can understand what we are talking about. Now, listen to me. For example, we have y is equal to 10 raised to power x. Y is equal to 10 raised to power x. Now we want to convert this to logarithm. We want to convert this to logarithm. It's going to give us log base 10 equal to x, then y. So we are going to have log y base 10 is equal to what? X. Log y base 10 is equal to what? X. Now, the way I explain it again in class is, let's rewrite this. This is x equal to log y base 10. This 10 came here and lifted this x up. So what happens is, you now have y is equal to 10 raised to power x. This 10 came here and took this x as its power. This 10 came here and took this x as its power. So this x now became the power of this 10 you are seeing here. That's why I said logarithm is the inverse of what? Indices. Logarithm is the inverse of indices. So we are going to try out some questions. We are going to try out some questions together. For example, we are given log 27 base 3 to simplify. We have log 1000 base 10, log 525, then log 125 base 5. Now let's try to solve this together and see what we can get from it. So the first one, we have log 27 base 3. For log 27 base 3, remember, whenever you are solving logarithm, the major focus should be on the base, because it's the base that we use to resolve what is here. It is the base that we use to resolve the number here, right? So in this case, we are going to reduce 27 to fit into 3. We are going to reduce 27 to fit to what? Base 3. Now log 3 times 3 times 3. Because 27 is 3 times 3 times what? 3. So this is log base 3 raised to power what? 3. Now in logarithm, the power has to go backwards. The power has to go backward, meaning that this will give us 3 log 3 base 3. Now the power has to go backward. Now the power has gone backward. The next step is to understand, like I told you, that log a base a is equal to 1. So meaning that a log to its own base is 1. a log to its own base is 1. Meaning that log 3 base 3 is what? 1. Meaning that we have this to be 3 times 1. And what's 3 times 1? 3. So log 3 base 3 is 1. Meaning that we have 3 times 1. And what's 3 times 1? 3. So we'll go again. Log 27 base 3, you are going to resolve to the base. And whenever you resolve to the base, you have to ensure that what you have here will work in line with the base. And what do we have as the base? 3. 3 times 3 times 3 is 3 raised to power 3. And 3 raised to power 3 is 3 has to go back. That's 3 log 3 base 3. Then you know log 3 base 3 is 1 because a log to its own power is 1. 3 times 1. And what's 3 times 1? 3. The next step will go to question 2. Question 2, we are working with base 10. Now, if we are working with base 10, we have to convert what we have here to base 10. We have log 10 base 10, 10 raised to power 3. Because 1000 is 10 times 10 times 10, which is 10 raised to power 3. Now, this 3 has to come back, which will give us 3 log 10 base 10. Like I said in the class, a log to its own base is 1. So meaning that 3 times 1. And what's 3 times 1? 3. So the answer to this is 3. The next question we have here is log 25 base 5. This will give us log base 5, 5 raised to power 2, 2 log 5 base 5. And this is a log to its own base is 1, which is 2 times 1. And what will 2 times 1 give you? 2. So the answer to this is 2. Then finally, we have another question which says log 125 base 5. For log 125 base 5, it's also very simple. We have to resolve this to base 5. And this will give us log base 5, 5 raised to power 3, which is 3 log 5 base 5. And this will give us 3 times 1. And what's 3 times 1? 3. 3 times 1 is 3. Now, this is very simple. Very simple, right? Yes. Now, moving on. I gave you some rules. I'm going to clean this off. I gave you some rules which you need to take note of. The first rule which I gave is a log to its own base is 1. That's the first rule. Then another rule which I'm going to give you now is whenever you have a log to power x and the base to power y, there is something that needs to be done because the powers are different, but the numbers are the same because the number relates to the base. In some cases, this number here is far bigger than the base, but the base has to be taken to where the number is, and that's where there's a challenge. You have to ensure that the two numbers they match so that they can work together. If they don't match, there will be a very big challenge. That's why you have this rule to become a. You come again and write x over y log a, and this will give you x over y. So it may look strange to you, but what needs to be done is to use your knowledge to solve this question. So questions like this are very simple, but you may not really know that this is what you need to do. So in this case, we have log 100. Then this is 0.001. Now, then in this case, you have log 749. What will you do to solve this question? That is a question we'll ask ourselves, and we are going to critically analyze it to solve it. Now, in this set of questions, or in this question, we are going to reduce log 0.001 to base 100. Let's see if we can get something out of this. So we have log 100. This base 100. You know that whenever you have 0.001, is going to be, where you have the decimal point is 1, 0, 0, 0, which is log 1 over 1000 base 100. Base 100, which is equal to log base 100. What we have here, remember, 1 over 1000 is equal to 1 over 10 raised to power what? 3. And when you have 10 raised to 1 over 10 raised to power 3, to take it up, it has to become 10 raised to power minus 3. So in this case, we have 10 raised to power minus 3. But can we leave it like that? No, because this is 10 and this is 100. Can you relate 10 and 100 together? Yes. But that is where we come back to this rule where we have log a raised to power x base a raised to power y will give you x over y log a base a, which will give us x over y. So in this case, we are going to simplify this, which will give us log 10 raised to power minus 3. We are going to reduce this to 10 raised to power 2, because 100 is 10 raised to power what? 2. So we are going to simplify. This is minus 3 over 2, because you know that x over y. Where is x? X is a raised to power x, then a raised to power y. So what we have here is minus 3 over 2 log 10 base 10. And a log, remember, a log to its own base is what? 1. So in this case, we have equal to minus 3 over 2, which is minus 1 over 1 over 2. First thing you need to take note of, it's not going to always be that the base is what we are going to use. So in some cases, we have to ensure that we make the number to fit into the base so that we can get what we want. But whenever we've not done that, there will be a very big limitation along the way. So ensure you make sure that the two bases, the base and the number, match. That's why we use this rule. Then another one, we have log 7 base 49. In this case, 49 is greater than 7. Will you just do it like this? No. You will simplify. You come here, log 7. 49 is 7 raised to power 2. Now, anything raised to power 1 is that thing. Anything raised to power 0 is 1. So 7 is raised to power what? 1. So if 7 is raised to power 1, we are going to bring it back. Remember, a log a raised to power x, a raised to power y. So we are going to have 1 over 2 log 7, which is 1 over 2 log, you remember, log to its own base is 1, which is 1 over 2. To give us 1 over 2 as our answer. So because 1 is going to be up, 2 will be down. Log 7 base 49 is going to give us 1 over 2. 1 over 2. Now that is that for the first part of logarithm. We'll be moving on to the second part of logarithm, which you need to know. Now, in the second part of logarithm, you need to take note that addition becomes multiplication. Subtraction becomes division. But same base. But they have to be what? Same base. If they are not the same base, this rule will not work. So for example, we have log 10 base 10, this base 10, we have 5, then we have plus log base 10, we have 30, then we have minus log Base 10, we have 25. In this, it's very simple. All we have to do is to write equal to pick log, take the base, open a bracket, pick 5, multiply it by 30, and divide it by what? 25. Because I said in addition, it becomes multiplication. In subtraction, it becomes division. So 5 year 1, 5 year 5, 5 year 1, 5 year 6. So this is going to give us log 6 base 10. But because we know we cannot simplify this further, we'll leave our answer like this. We'll leave our answer like this. So that is it. So when you have addition, it becomes multiplication. And when you have subtraction, it becomes division. Take note of this valuable point. It is going to be very helpful to you in the long run. Take note that when you have addition, it becomes multiplication, and when you have subtraction, it becomes division. Take note.